Hi everyone. In this video we will talk about the topic of annuities. An annuity is a savings investment plan in which the investor makes a regular fixed payment into a compound interest account where the interest rate doesn't change during the term of the investment. You may already be familiar with annuities. Often a family or a person will use them to save money to pay for things like college expenses or a vacation, or a very common one is to use them to save up for retirement. So you are allowed to make regular contributions to this savings plan, and the interest rate doesn't change over the term of the investment. So that's nice because it's stable. So if you're counting on this for retirement, then you might be interested in something that guarantees a certain rate of interest. The total amount accumulated for an annuity is called the future value, and we find the total amount just by adding the interest plus all of the payments. So normally in the past we've talked about a future amount is the principal plus the interest, but here, since payments are also being made, it's almost like that principal increases over time with each of those payments that's made toward the annuity. The other difference from a savings account is that the payments for an annuity are made at the end of each period. So when you start an annuity, if you think about a period of like once per year, then your first payment would be made at the end of the first year instead of at the beginning. Alright, so let's try an example. Let's find the future value of an annuity. This is one that has a $500 payment made annually for 3 years at 6% interest. And here the interest is compounding once per payment period. Alright, so for the first year, the principal is $0. Nothing is in the account at the beginning of that first year. It's not until the end of the year that that payment of $500 is made. Alright, so if there is no principal, then no interest can be earned in that first year, and so then the total value at the end of the first year is just that $500. Now the second year, the principal is whatever is in the account previously, so that's going to be $500, and now we can calculate interest. Interest is calculated using compound interest, but in this case, since we're just making a payment and interest is compounding once per year, alright, n is 1, and we're only looking at a time period of a single year. So in this case, we can actually just use the simple interest formula, which is the one that we use when we have an n and a t both equal to 1. Alright, so to calculate interest, we just want to take 6% of 500, and then your time is 1. You're multiplying by 1. So you can skip that if you want to. Okay, so 6% of 500 is $30. And then at the end of the second year, another regular payment will be made, another 500. Right, so the total value, you would add up all three of those numbers, and the annuity would have $1,030 in there. So the third year, the new principal is going to be the balance from the previous year. Then to find interest, take 6% of that amount, and that amount would be $61.80. Then at the end of the third year, another payment is made, and then if you add those three up, that gives a total future value of $1591.80. Okay? Now this is kind of the long way. This is similar to what we did when we looked at the long way to calculate compound interest. And we would need to make one of these calculations for every single time the interest compounds. So if we had an annuity that compounded monthly, maybe somebody was contributing to a retirement account and putting in an amount each month. So then you would have 12 of these calculations per year. So for 3 years, we would need, 36 different rows here. So again, this is too time consuming, and we do have a formula that is a shortcut for finding the future value of an annuity. All right, so many of these variables you're already familiar with. A is the future value, little r is the annual interest rate, we have T for time, and then N is still the compounding period, and the compounding period always matches however many payments are made in a year. And then the new variable, the capital R, that's the regular periodic payment. So you can think of that as kind of taking the place of a P for principal. Alright, so let's try this out. Here's an example. You open an annuity with semi-annual payments of $800 at 5% compounded semi-annually for 4 years. So notice the payment period matches the compounding period. Okay, find the future value of the annuity and then find how much interest you earned on the annuity. So we want to use the formula for the future value of an annuity and substitute in all of these variables. Okay, so we have 800, and I'm going to write this how you would write this in a calculator. You'll get the most accurate answer if you just enter this all in. So I think most calculators just use parentheses instead of brackets. So we'll go ahead and just use that. And you just use a double parentheses here. Alright, and then you have 1 plus. The rate as a decimal is 0.05. You can use the division sign to show a fraction. N is 4. Close that parentheses. And then use a caret for an exponent, or some calculators use a y to the x key. Alright, so you would type all of this in, then hit the y to the x key, then start typing your exponent. Now we have two things in the exponent, n and t, so we need parentheses to show that both of those are part of the exponent. Okay, so n is 4, n is 2. This is semi-annually. Okay, and then T is for the annuities open for 4 years. Close the parentheses, we're done with the exponent. Subtract 1, and then we need another parentheses, that's this bracket in the numerator. Okay, and then we can still keep going, so put another, I'm going to need a new line here. Okay, next thing you type is a division symbol, and then for the denominator, again, we have a fraction in the denominator, so you need parentheses around this as well. So parentheses, then the rate, 0.05, divided by 2, parentheses. Okay, and that should be good for your calculator. Notice if you have something in parentheses that works out to be an exact decimal, then you can figure that out ahead of time. So maybe even for the denominator here, you could figure out what 0.05 divided by 2 is, and then you would not need this parentheses in the denominator if you're just entering in one number. Okay, so try that out and see if you get the same answer that I do. And I have $6,988.89. Okay. So one thing you can do, just check to see if this seems reasonable. Twice a year for 4 years, so 8 times, a payment of $800 is made. So that's $6,400 right there. And then, the rest of this as an interest amount, that seems reasonable. Okay, so that's the future value of the annuity. Then how much interest will you earn? Well, if you go back to the definition of annuities here, or the definition of future amount, okay, it says the total amount accumulated, payments plus interest, is called the future value of the annuity. So if we want to find just the interest, then we need to take the future value and subtract away all of the payments. Okay, so I just mentioned that part of this. Figure out how many payments were made. So we had twice a year for 4 years, 8 payments, and then 8 payments of $800 is $6,400. So then you take this amount and subtract $6,400, and then that tells you that the interest is $588.89. Okay, so that's part B. If you open an annuity, okay, so same problem here, semi-annual payments, $800, 5% compounded semi-annually for 4 years. How much money would you have to invest in a regular savings account at 5% semi-annually to get the same future value after 3 years? All right, note that your first payment on the annuity is at the end of the first year, so that would be when you make the lump sum investment, giving you just 3 years of interest. So what we want to do is just compare, see which is a better investment, a regular savings account or an annuity. All right, so we want to use the compound interest formula. Okay, and then since based on this note here, we want to consider the time period to just be a 3 instead. Okay, we only have 3 years. So we have the same principal, and let's see. Actually, I think we're looking for the principal here. We want to get the same future value. Okay, so we need to substitute in the same future value, $6,988.89. Figure out what principal would need to be invested to get the same rate. Okay, so we have a 5% rate, compounded semi-annually for just 3 years. Okay, so what we want to do is work out, let's try to simplify all of this on the right. Okay, or another option is to just divide both sides by that whole amount. So let me show you what that would look like on your calculator. Now if you want to solve for P, you would divide both sides by the rest of the term that's over there, the stuff that's multiplied by P. Okay, so that's this line. And then to enter this in, you don't need parentheses around the numerator because it's a single term, just one number. But you do need parentheses around the denominator. Okay, because we have this portion in parentheses raised to an exponent, and then you need parentheses around the exponent, 2 times 3. Now it doesn't hurt to put parentheses here around the entire denominator, but you don't need those because your calculator is using order of operations. So it's going to calculate this exponent before it goes on to do this division. Alright, so if we calculate this, this gives the principal, and that gives, should be 6,026 and 40, let's see, 0.497, so that's going to round to 50 cents. Alright, so if we compare that to the annuity, notice the annuity with all of those payments, you ended up investing $6,400. However, the difference is that with an annuity, that amount was distributed over those 3 years. It was once at the end of each period, so only twice a year you were contributing $800. Right now here, this needed to all be put in there at the end of the first year. Alright, let's look at an example of finding the monthly payment for an annuity needed to reach a certain goal. A financial planner estimates that you would need a $35,000 initial investment to start your own business, and you plan to save that amount over the course of 5 years by investing in an annuity that pays 7.5% compounded weekly. How much would you need to invest each week? So what we're looking for is R, what is that regular weekly payment that needs to be made. All right, so we're still going to use the annuity formula, just solving for R this time instead of the future value. So let's pull that formula up. Here it is. And we need the future value to be 35,000. We would like to solve and find R. We know that the rate is 7.5%. This is compounded weekly, so that would be 52 times per year. And this is over the course of 5 years. Okay, minus 1 bracket, that's the rest of the numerator. And then divided by rate over n, 0.075 over 52. Okay, so enter this in your calculator. You can use parentheses instead of brackets. Make sure to put an extra parentheses around the exponent and one around the denominator. All right, so let's talk about solving for R. So let's do this a couple ways. So one, we can try to simplify everything on the right-hand side first, and then we'll divide both sides to solve for R. The other way we can do this is by rearranging the formula right now before making any of these calculations. Okay? Okay, so if you work out the right-hand side, everything except for R, then I'm getting 315 point, and I'm going to round to 2 decimal places, so 0.19. Alright, so try it out, see if you get that amount. And then when you divide both sides by 315.19, I'm getting the regular payment to be 111.04. Alright, so that's just one option. You may have chosen to use this method but rounded differently at this step, and then you would get a slightly different regular payment. Now let's talk about just solving for R. Okay, so if I wanted to use algebra to isolate R at this point. All right, first thing I want to do is multiply both sides by this, by this fraction in the denominator, and that way I can move that over to the other side. Okay, so we would have 35,000 times 0.075 divided by 52 on the right hand side, or on the left. Okay, and then I want to divide by all of this stuff with R to get R by itself. So divide by a big parentheses. Okay, that's kind of like, or I guess we could even use a bracket at this point. That's the formula. A bracket, and then parentheses 1 plus 0.075 divided by 52 to the exponent of 52 times 5 minus 1. Okay, and then you could use your calculator to just enter that in as is, and you would just put parentheses everywhere that you see them here, and I think the only other thing you need to do is just put parentheses around the exponent 52 times 5. So try that and see what amount you get, if it's a little bit different because of the rounding that we did previously. And I think we were pretty accurate last time. I tried it this way and I'm getting 111.044, so that rounds to $111.04. Alright, that's it for annuities. So you might want to try some extra examples. Let's review the few things that we've talked about. Okay, we have the idea of what an annuity is. It's usually a slightly higher interest rate, and instead of investing a principal right at the beginning of the term, you are making regular payments throughout the investment period, and interest accumulates on those. We talked about how, kind of the long way of how the future value is calculated, but the main formula that you need to know is the shortcut, the formula for finding the future value of an annuity. And then from there, we could do the same thing to find the interest as we do with compound interest, like savings account type situations. So you would take that amount and subtract all of the payments to find interest. Okay, and then we could also solve for different portions of this equation. The one that we looked at is solving for R to find how much you would need to regularly contribute to an annuity to reach your goal. As an extra exercise, if you're interested, maybe think about what amount you might like to earn in the future if you were to start an annuity. So think about a long-term savings goal, something like, you're already through probably college at this point, but think about maybe purchasing your first house, or saving for retirement, or if you have a large giving goal in the future, maybe you could use an annuity to save for that, and then see what that regular amount would be that you would need to contribute to reach that goal. You may need to do a little bit of research, look at some different banks or financial institutions, and see what some of the going rates are for annuities. Okay, so that's it for annuities, and we will pick up after this in another section and start talking about installment loans and credit cards and different interest rates, ways of calculating interest on credit cards.